Hi, I have a question for you. Can you read the title of this lecture? Yeah? And how about now? Isn't it a little bit more difficult? Yeah. So this is how I see it, blurry, and it's significantly harder for me to read this text. So hi again, I'm Asya Frumkin. I have a bachelor's degree in computational biology and a master's degree in computer science. I live in Israel and I work as an algorithm developer for a small startup called Evinced, which is based in Tel Aviv. And in my free time, I love traveling and hiking, and my love for traveling led me all the way to Antarctica a few years ago. But until this point, I haven't explained to you why I see blurry. And in order to understand it, we need to go back in time to the moment I was born. Because right after I was born, I didn't respond to light stimulations, and so the doctors suspected I might be blind. But after a while, it was discovered that I just don't see well, and I was diagnosed with albinism. So what is albinism? Albinism is an inherited condition that manifests itself in a lack or deficiency in the pigment melanin. And melanin plays a crucial part in the development of the eye in the embryonic stage. And so people with albinism tend to have many vision problems. And some of those problems you can see in those embarrassing childhood pictures of mine. And here you can see problems such as a lazy eye, crossed eyes, and you can see the glasses that I wear from the very first moment I can remember myself. So what does it mean for me to be an albino and to be visually impaired in my everyday life? It means that I have problems reading small text in print. I have problems reading text from the blackboard in the lecture hall. And I even have problems reading my own lecture notes when I speak in public, as I do right now. As a computer user, I always enlarge the text in all the programs that I'm using, and many times I struggle to find the option of the font enlargement option in the programs that I'm using. As a data scientist, I work usually with visual data, and so many times I try not to rely on my vision, but rather use statistics or the opinions of people around me in order to make the right decisions for my research. However, my story is not unique. As of 2015, there were over 250 million people over the world that were visually impaired, out of which 217 million people were moderately to severely visually impaired, and 36 million people were blind. So all those people consume technology just like anyone else. And there are many tools, assistive tools, that help them do so, such as screen readers and magnifying glass software. However, websites and mobile apps need to be built in a certain way for the assistive technology to help those people get the full information from the websites. And the company I work at, Evinced, focuses on digital accessibility. And so at Evinced, we believe that accessibility is the responsibility of the developers. And so we build tools for developers and for companies that enable them to incorporate accessibility into their products. And in this way, we help people who are visually impaired and people with disability use the web better. So until this point, I introduced myself and I told you a bit about what it means for me to be visually impaired. And let's see a specific problem that a person who is visually impaired or colorblind might face. And so we can see here two buttons that are identical in everything except for the background color of the button. And the upper button is light blue and the lower button is dark blue. and the text overlaid on the buttons is white. And so the color contrast between the light blue background and the white background is too low. And so a person who is visually impaired might not be able to read the text on the button. And so he might not be able to use this button. And if it's a part of a major flow in a website, basically this flow won't be usable for this person. So how do we know if a color combination is accessible or readable for people who are visually impaired? So there actually exists a mathematical function that computes the contrast ratio between two colors. And according to this mathematical function, one can determine if this color combination is accessible or not. And there exists a standard that specifies exactly what should be the color contrast ratio in different cases. For example, where the font size is 18 pixels or 14 pixels, if the text is emphasized or not. And so this is actually like a solved problem. However, what happens if the text is overlaid on a complex background, such as a gradient or an image? So in this case, the text might blend into the image, and so it won't be readable and accessible for a person who is visually impaired. And in order to assess the readability and the accessibility of this text, there are people whose job is to assess accessibility of websites, and they might use this mathematical function to calculate contrast ratio for specific pixels around the text. And so by using this method, which is like manual and takes time, they might assess the accessibility of this text. However, there is no automatic tool that does that. And this was my goal. Given a text that is overlaid on a complex background, my goal was to classify it into a text that is readable or not readable. Okay, so we got the problem definition, and let's see how I started tackling this problem. So first, I tried to use a POC code, an existing code that relied on synthetic data. And in this code, it basically used an OCR engine called Tesseract. So OCR is a technology that enables to extract text out of images. And this code worked in the following way. So it got an image with a text that was inserted into it, a known text. And after that, an OCR engine ran on this image and extracted a text. And the next step, the extracted text was compared with the original text that was inserted into the image. And in case they were equal, the text was considered to be accessible and readable. And if they weren't equal, the text was considered to be unreadable. So basically, this is the POC idea, and I wanted to test it on real-world data. The problem was I didn't have data, and so I had to gather it. And in order to do so on the web, it's fairly easy to scrape data, and I use my JavaScript and my knowledge of the way websites are built in order to scrape pairs of images and text. Basically, the images showed how the text looks on the web page. And so I tried to use the methodology I explained on those pairs. And let's see what I got. So here is an example of a text that is very clear to us and very readable. However, Tesseract, the OCR engine that I use, returned an empty string. Strange, right? And here is another example where the text is very clear and very readable. However, Tesseract returns pure gibberish. And so I tried to understand why I'm getting those unexpected results, and I dug deeper into Tesseract engine and the technology, and I found out several interesting facts about Tesseract. So first of all, it's an OCR engine that is meant for detecting text on documents, meaning black text on a white background. It has a really nice Python library that wraps it, and so it's a really useful tool for prototyping, as it also supports many languages. And it's actually fairly easy to train Tesseract on new languages or new characters. However, Tesseract works best on high image quality, over 300 dpi, whereas the data I got from the web was 72 dpi, which is much lower. To improve Tesseract's results, one can perform pre-processing on the data, such as transferring the images to black and white or reducing noise, and this can improve results. However, I didn't want to do such thing because I suspected that it might harm my classification. Another thing that affects Tesseract is font size, and it performs worse on texts that are really small. And it also returns strange results on special characters such as currency signs. So I understood that Tesseract is not the right OCR engine for my needs, and I started searching for a different OCR engine. And I stumbled upon a post by Jan LeCun, who is the head of AI in Meta and one of the godfathers of deep learning. And in his post, he recommends a new OCR engine called EasyOCR, which is meant for detecting text in the wild, meaning text that exists in a natural scene, such as a street sign. And so I decided that if Jan LeCun recommends something, I should definitely try it. And let's see how EasyOCR works. So EasyOCR gets an input image and does pre-processing on the image. In the next stage, it performs a text detection using a model that is called Craft. And please remember the name because we'll talk about it later. The next stage is text recognition, where basically the parts of the image that were recognized as text before are translated into a sequence of characters. And in the last stage, a decoding process runs and translates the sequence of characters into a meaningful text. So we can see here that EasyOCR works better on the example we saw before that Tesseract struggled with. And here is another example where EasyOCR works better. However, it's not perfect, and it makes mistakes on other kinds of text, such as here we can see that it makes mistakes on the percentage sign. And we can see now what I learned about EasyOCR. So EasyOCR is an OCR system that is meant for detecting text in the wild. It's based on PyTorch, which I personally think is a pro, but not everyone would agree. It's a really modular system, and basically each part of the system can be replaced by a different model or a different system, and it's really a huge pro, in my opinion. And as the name suggests, it's really easy to use. There is a really nice Python library that enables using EasyOCR for any OCR requirements. The cons that I saw were that EasyOCR performs worse on black and white images, where Tesseract excels, And it also makes mistakes on special characters, such as dollar signs and percentage signs, and etc. And so at this point, I came to a conclusion that I tried using two OCR engines, Tesseract and EasyOCR, for my project, and none of them was suitable for my task. I thought about maybe combining them together into a big system or trying a different OCR engine, but I felt that I'm getting into a more complicated scenario, and if I would combine a few systems, it would be hard to debug and maintain. And so instead of going in this direction, I did some kind of root recalculation, and I decided to try a different approach. And the approach that I tried was basically to use, instead of using code that existed before, to use all the knowledge that I got in the process and incorporate it into my own solution. And my solution was based on three very basic principles. The first one is splitting a big problem into smaller problems. The second one is using only the relevant existing parts instead of like big black box systems. And the third one is finding the right balance in my data set to get the best model. And let's go over each one of those principles. So the first one is splitting a big problem into smaller problems. We can see here a text over a complex background. It's written here, feel good. And we can see that the text here is problematic, but we can't really quantify it. However, if we look at each character, we can easily decide that the E, for example, is readable, and the O is very not clear and not readable. And so if we go over each character, we can see that in this text we have 4 characters that are not readable out of 8, meaning that the contrast ratio or the ratio of characters with bad contrast is 0.5. And if we have a predefined threshold, for example, as 0.4 before, then we can see that according to this threshold, this text doesn't pass, and so we decide that it's not readable. So the second principle is using only relevant existing parts. So in the beginning, I tried to use big OCR systems that were composed of many small pieces and small parts. And when I got unexpected results, I couldn't debug it easily. And so instead of using whole systems as black boxes, I decided to use only a small part of EasyOCR, the model craft, in order to detect and extract specific characters. And craft works in the following way. So craft basically calculates the probability of each pixel in the image to be in the center of a character. And based on this probability, we can build a heat map where the areas with a high probability would be more red, and the areas with low probability would be more blue. And based on this heat map, we can crop out all the characters into single character images. And over each one of them, we can go with a binary classifier and decide if each one of those characters is readable or not. And this leads me to the third principle, which is finding the right balance in the data set. And so I decided to model the problem of classifying a specific character into a readable or not readable character into a binary classification problem. However, it's actually not really binary, as there exists a scale where on one side we have characters that are very clear and very readable, and on the other side we have characters that really blend into the background. And this scale is actually unique for each person, whether they are visually impaired or not. And so in the beginning, I had a set of many labels of characters overlaid on a complex background that were subjective because of this scale. And when I tried to create a model based on those labels, my model didn't perform well. And instead of basing my model on subjective labels, I decided to enrich my dataset by using objective labels where characters were overlaid on a plain background. And for this type of data, I had a clear standard that defined objectively which characters are readable and which are not. And so I did a series of experiments where I tried to balance my data during the training, and in the end I got the model I was satisfied from. So how does the whole system work? So the system gets an input image and a text. After that, the model craft runs, and it extracts basically each character into an image, a small image. On each one of those characters, a binary classifier runs and classifies each character into a readable or not readable character. And after that, we calculate the bad contrast ratio out of the entire characters in the text. And in the end, we use a threshold in order to classify the text into a readable or not readable text. So until this point, I told you about how I started this project of classifying a text overlaid on the complex background into a text that is accessible or not. In the beginning, I tried to use different OCR architectures to solve my problem, and I told you how I got into problems using this approach. And so I decided, instead of going and complicating my solution, I decided to reframe my problem, and this led to a breakthrough and to a solution. And we can see now how it looks in one of the products of our company. So basically, this is a product called Site Scanner. It scans complete domains of our clients for accessibility issues. And one of the issues that it detects is the issue that I'm talking with you about. And so here we can see some of the results of texts that are really not clear and not readable and not accessible. And when I ran my system on big amounts of data, I discovered that this problem of texts that are overlaid on complex background is more affects more a specific domain, such as traveling and news and art and design. Domains that are more visual and try to appeal to the users by using a lot of images and videos. And here we can see some examples of texts that were classified as not readable by the system. And we can see that those texts are actually not clear and not readable for many people. 50 million people who are visually impaired. And the solution I showed you help helps all those people in their everyday life. And so I encourage you to think how you can incorporate accessibility into your work, either if it's in how you build your presentations or create a plot, or even in how you write your code. Let's together make the world more accessible and inclusive to people with disabilities.
So, thank you very much, Asya. We have one question in Slido from Vsevolod. How does your approach account for different kind of color blindness? Are there modified contrast ratio formulas for that?
Yeah, so...
Oh, no, you can...
Okay.
Yeah, sorry.
Okay, so actually the mathematical function that I talked about in the beginning for contrast ratio also incorporates people who are colorblind, and so it incorporates it into the calculation. However, it's an area that is evolving, and there are many improvements to be done, and so there are standards, and they improve all the time. So I hope it would be better in the future.
Yeah, next question. What can Python developers do to increase visual accessibility?
Yeah, so actually it's a really good question. There are many rules for creating things that are, or plots that are accessible. For example, like some basic rules are, for example, not to use green and red in the same plot, because people who are colorblind can't really distinguish between them. Other things are like using larger fonts, and also add, instead of like coding something with color, adds another option, not to use only color but also text or more information, because some people don't see color well, and so they lose this information. Yeah.
Can you recommend maybe some resource for the, like, where we can find these rules, like how to educate ourselves?
Yeah, so the standard is called WCAG or WCAG, and basically the current standard is 2.2, I think, if I'm not mistaken. And there you can see all the guidelines. They're quite cryptic to people that really are not in the field, but there are many blog posts about this topic, and so you can go online and look for the information.
Yeah, at least start with something.
Yeah.
Yeah, and I think that will be, unfortunately, the last question. Does a border around characters help even if they are very thin? Well, this is very specific.
Yeah, so actually, yeah, there is like a specific WCAG specification for that, and it depends on the border. Like, it should be like 2 pixels or more, and depends on the size of the border, but yeah, it's really specific.
It's complicated.
Yeah.
So, okay, thank you very much. Unfortunately, we can't answer all the rest of the questions, but Asya is around. I think she will be happy if you approach her and ask more questions about this topic. Thank you very much.
Thank you
for being here.
Yeah, and thank you for